Hello, everyone. Jeremy Hamilton here, BMC's Big Iron Guy. And today I'm joined by the Dr. Z, Don Zeunert, and we're going to be discussing a topic that is near and dear to my heart, yet often overlooked in the context of DevOps, and that's mainframe infrastructure. Specifically, some areas that can help break down the communication and cultural barriers between DevOps and product teams and the infrastructure teams. So, Don, anything to say before we get started?
No, so you're representing dev, I'm representing ops.
Sounds good. Well, the gap between development teams and operations is not a new one, especially on the mainframe. For as long as applications have been developed, code changes, requests, and requirements have been tossed over the fence from product teams to small, outnumbered staff of shared resources. That's the team that keeps the lights on, the DBAs, the sysprogs, and admins. With such a backlog of work items, there's no real visibility into the why behind them. Most infrastructure teams have followed the waterfall methodology, using a first in, first out approach and often batching up the changes in order to gain some control and efficiency. Then along came DevOps and Agile, which completely changed how the product teams operated. It replaced those static project plans with a constantly shifting backlog and smaller units of work. This has put more volume and pressure on infrastructure teams to keep up, not to mention the big elephant in the room, brain drain. And that's from the skilled resources starting to lead the workforce. To illustrate this a little differently, let's take a look at the Agile iron triangle. On the left-hand side, we have the traditional waterfall way of working. This is where there's a fixed scope. I'm going to do XYZ work in some certain order. And that often led to cost and time overruns, and even quality was a variable there. In the middle, you have the Agile triangle. With Agile, cost, time, and quality are fixed, but the scope was allowed to shift to adapt to the changes and what was needed. Great for development, but not so great for infrastructure, who now has to deal with the many small changes and very little visibility into what's coming next. And when all that happens, costs inevitably will go up, quality can suffer, and time can be exceeded as well.
So that leads us into the pains that we're talking about. So we're I know that CIOs and technology directors, one of their things that keeps them up at night is they're going to miss their deadline, and you miss your deadline, and it costs the business money in terms of not being the first to market and lost revenue opportunities. And one of the reasons is the mainframe shared resource shortage, which is only getting worse. If you manage to find someone that still knows IMS, for example, he doesn't know your business, and it's just not going to be as productive. The developers are working on systems, and everybody says, cut the cost on the mainframe, cut the cost on the mainframe. And so, they've laid off everybody they can, and now they're constraining the CPU resources, and developers' productivity is stifled. So another reason that they're going to miss their deadline. And we'd like to talk about ways to help reduce both of those issues. And then, of course, there's quality issues, because they can't get the testing done, also due to lack of resources. Maybe the SASE to make it happen, or the CPU to do the testing. And we test things the best we can, and then we roll them out, and we miss the service levels because someone didn't do the capacity planning for what it's going to take for this new hot application. So there's increased unplanned resource utilization, which causes budget overruns in the short term in terms of IBM software license costs, and in the long term in terms of hardware. And to add insult to injury, the sysprogs spend a lot of time firefighting, which distracts from their ability to attack that queue. So we want to talk about how we can collaborate and have, when they have those shifting the queues, shift things in their queue, instead of us having a FIFO queue, have us a queue based on the sprints that are occurring and have more feedback into the whole process. Jeremy?
Agreed, Don. And sometimes you have to fight fire with fire. I believe the solution is that you have to apply the core DevOps principles outlined in the 3 ways to the infrastructure work being done. The 3 ways is DevOps at its simplest. It takes a good look at the value stream. How is value delivered? What is actually needed to be delivered? And then integrates in continuous feedback loops to help identify and eliminate wasteful areas in the process. And finally, adopt a mindset of continuous improvement, always looking for ways to improve on the process. What really brings those 3 ways together are the items that are in the middle there. A culture of collaboration, working together with dev teams to provide feedback and input into changes. Automation, taking mundane tasks off the backlog of your precious shared resources, freeing them to do more value add work. Monitoring, you can't improve what you don't measure and you can't fix what you can't see. So, monitoring is a huge part of the 3 ways. And sharing, not only sharing of experience, but also sharing of duty, sharing of success, and failures. I put one more item here at the very bottom, and that's AI and ML. As of recent, because of the sheer volume and complexity faced by most infrastructure teams, AI and ML become a valuable component of the DevOps approach. And as Don said a little bit earlier, it all starts with collaboration. 80% of the world's data resides on the mainframe, so it makes sense that those responsible for keeping that data available should be involved in the planning. Infrastructure teams know how the applications run in the real world and can provide feedback into the dev teams on how to make their applications runs better. You think a sysadmin could tell your dev team about performance? Of course. Who would know better? You think a DBA could help you improve an application's handling of data? Absolutely. On the other hand, if you're an infrastructure team and you're wondering how to insert yourself more into the dev planning, think data. Nothing will get a dev team's attention like bringing them insight into how their application is running today and what to expect going forward. So things like modeling, capacity reporting, anything that puts real data to what the dev teams are doing is a great way to do that.
So thanks, Jeremy. One of the other things is that we need to know what's going to happen with these applications. And as I said, a lot of people are doing mainframe Agile now, but even if you're just doing distributed Agile, because the data and the old applications that you're making look pretty are consuming mainframe resources, and because of the tendency to try to cross-sell additional services when you are trying to do something simple. For example, I just wanted to check my transaction balance, and marketing people decided on the distributed thing that they should put loan approval in there and tell me how good of a rate I can get. That's extra cycles on the mainframe that were unintended. So what we want to do is model what's going to happen with your change. And this tool, BMC AMI Cost Management, allows you to grow or shrink applications in terms of report classes or address spaces, etc. Next slide. The other thing we want to talk about is feedback, anomaly detection of application behavior. So you rolled out an application change in low season because that's when you're allowed to roll out the change, and the monitoring rules are set very high for high season, and so they won't trigger an alarm. But BMC AMI Capacity Management has machine learning and automatically does anomaly detection, and it can detect it on resource utilization, response time. So we can look at CPU per transaction or something that's happening that's unrelated to an increase in volume just because your application makes things easier. But you can also see, I saw one customer where a specific transaction they've been running for a long time, they ran 200,000 a day, and then it jumped more than double to 500,000 due to a distributed application change. So we want to be aware of those types of things, and this can detect those. Next slide.
All right. Thanks, Don. Well, next is automation. No one wants to slow down progress, and there's not enough time in the day to do everything. So, automation is really the only force multiplier. Automation takes mundane, repetitive tasks off your admin and DBA's backlog while improving the quality and speed with computational precision. On the dev side, there are a lot of areas which have already been automated, but here you might not here are a few that you might not think about from an infrastructure perspective when it comes to applying automation. Like I said, modern development staff have access to tools that automate nearly everything throughout a CI/CD pipeline, and that speeds up development and deployment. That is until a database change is required. At that point, a DBA has to get involved, and which stops the pipeline, and he or she checks out the change. Not to mention pulls him away from whatever, or him or her away from whatever they were doing. Often that change isn't up to standards, and so on the first pass, so they go through some back and forth, and finally they'll become to a mutually agreed upon change. Again, it's a tedious workflow where many of the steps should and could be automated. With BMC's AMI DevOps, we automate the change process through BMC's Change Manager. This automatically generates the required reports that describe the change, plus builds out the jobs that are needed to deploy or roll back the change. The DBA can have as little or as much to do with the deployment of the change as they want, and that may vary depending on where it's at within the life cycle. Now, I've seen it implemented many different ways, and some DBAs like to be involved up front during the dev and test phases so they can catch problems early. Others don't want to see the changes until it gets promoted through up into a test environment or even into pre-prod. Either way, AMI DevOps reduces the interactions by automating the progression of those changes through the different environments. And that takes loads of work off the DBA. Another potentially time-consuming, tedious task is database maintenance. Everybody knows that a database will perform its best right after a reorg. That then, as the week progresses or time progresses, the data gets disorganized, and the response times can elongate. You get increased CPU from having to work harder to get the data. Yet most shops still only perform weekly reorgs, usually during a quiet hour on a Sunday, and then they reorg everything, whether it needs it or not. The solution? Reorg more often and only what needs it. BMC's database utilities for both DB2 and IMS use AI to detect which databases are in need of reorging and leave the rest alone. And since you aren't reorging the entire world, this frees up a lot of resources, which I'm sure the development team will be glad to take. Plus, our tools allow zero outage maintenance, which allows you to take advantage of windows of your choosing throughout the week to get the database maintenance done. Optimized databases make your applications happier, and the automation takes this work item off of your DBA's backlog.
So, Jeremy talked about how we can take work off of the DBAs in determining what needs to be reorged or improving efficiencies and not wasting CPU by reorging only what needs doing, which can help with the batch window, which is typically what's driving a lot of customers' IBM bill and hardware. The batch window, if you have MLC building or even new TFP billing, it is typically trouble for about 60 to 70% of the customers. If you hit your 4-hour rolling average peak at 9 a.m., it's probably because batch ran late and mixed in with the beginning of online, which is usually slow unless, say, you're a brokerage firm. But another advantage of the database utilities is they run about 85% faster with 85% less CPU. And so if you're in tailor fit pricing mode where every CPU second counts against your bill, the CPU savings is very nice. And even if you're an MLC, that's nice. But to me, it's more important to save the elapsed time to have the reorg while open. And the enemy in the batch window is elapsed time. If I could finish on time, I could cap and consume resources slower, or use another mechanism to consume resources slower. And there's lots of tools that you can have that will save elapsed time. And we're only going to talk about a couple of them here. But if you come and talk to BMC, we can talk about lots of things to help with your batch window. Next slide. So this is some actual customer data using BMC's ThruPut manager. And this illustrates that just submitting everything and letting it run and fight with each other causes it to run longer and use a lot more CPU. In this particular case, 52% more CPU and significantly more elapsed time, around 5 hours longer when people just submit everything and let it fight with each other. So it's one example of a BMC tool that can save elapsed time and save CPU. So no matter what billing model you're under, this can save you money. Next slide. The other thing we talked earlier about, the developer productivity being stifled, and many customers' IBM bill is based on month-end batch. And when I see a picture like this one, where all month long your CPU utilization is rather low, and then it just jumps up crazy to run month-end, everything here in the middle where I have the treasure test is lost. You're not going to pay for it. You could use all that and not pay for it, but someone has put a static cap on developer test LPARs to keep them under control at month end, but it's just static and they run with it all month long. We could raise, we could make that 4 times bigger. So you don't necessarily have to enter into a dev test container contract with IBM to increase dev capacity without impacting your billing. And dev test containers are another option. So we don't need to have the developers' productivity stifled because they can't get enough CPU. Next slide. So BMC has a tool which does dynamic intelligent capping based on workload importance, and you can cause it to steal from low importance discretionary work and give to high importance work like online systems or other even test kicks regions so that people can do some CICS or IMS testing development. In this particular case, the customer had static caps, and they said, I'm only going to have 1,000 MSUs a month that we're going to pay for. And so they decided to allocate them across their LPARs. Well, when you do a static cap like this, you can see that my main production region, LPAR 1, hit its cap and stifled all work, yet there was spare capacity on the other one, this white space below the line. So those, we didn't get billed. We said we're willing to pay for 1,000. We got a bill for that month for 811 because these guys weren't using theirs, and we hurt important work. If we look at what happens when you put dynamic capping in, it would dynamically say LPAR 1 is the most important LPAR. The most important work on that LPAR is hurting. Therefore, very first thing I'm doing is going to steal all the white space from all the LPARs. And so we've lowered their caps to where they're actually consuming the resource. And LPAR 3, the least important LPAR, was running low importance 5 work, and we stole and capped that LPAR further and donated those low importance cycles on a low importance LPAR to high important work on high importance. And I'm running at a lower MSU limit. I saved 161 MSUs versus the risk of having 1,000 but only getting billed 800, and yet my SLAs didn't suffer. And the same thing can happen where we have importance 1 work running on LPAR 3. We could steal from the other LPARs if they're running importance 5 work. Next slide.
All right, great. Well, the next piece is monitoring. And so unless you're running in a fully managed environment, your applications have to run somewhere. And then they touch various different parts of your system. Modern applications today span across platforms from cloud to mainframe. So keeping a watchful eye on how things are running, being able to determine where the issue is occurring, and then troubleshoot quickly is imperative to keep your end user happy.
So BMC has an end-to-end business service management solution that includes monitoring and capacity planning, and it's integrated with our mainframe and distributed discovery so that we can show you if a monitor generates an alarm, what its impact on what business service it impacts, and we can open service desk tickets and things like that. And we also feed into capacity planning, the discovered CIs, in this particular case, stock trader, and we can organize the capacity data around that and have other user-defined applications to the capacity product and track what's going on and, as I said before, automatically detect anomalies. Next slide. So BMC AMI Ops is the new user interface for MainView, and all of the MainView customers are entitled to this new user interface. And it allows you to edit the dashboard. It comes with an out-of-the-box one, which is organized by subsystem, and you can clone that dashboard so that it represents sets of KICS regions or IMS or MQ or DB2 that represent business applications. You could also clone it so it represents something as simple as prod versus test. But we're giving a single sign-on, single user interface capability to navigate anywhere, and it navigates easier and has all of the views that were in the various MainView products available to you. So there's that. So what we're saying is if you have a single place that you can go with the same look and feel for all of the products, with all of the metrics from all the products in there, instead of, well, this user interface has these metrics and this user interface has a different set of metrics. And if you want to look at a different subsystem like storage, you use a different user interface. You don't have to do that here. So it allows more productivity of your limited staff because they only have to learn one user interface. But as I mentioned earlier, the problem with monitoring is typically set up, even though this product can do dynamic thresholds by time of day, and we can say, I've got a threshold for, 6 a.m. to 10 a.m. And if I'm at my normal 1 o'clock threshold at 6 a.m., I've got a problem. Something is broken in my environment. Sometimes that's not enough because it takes too much work to maintain. And it's still probably set up for high season, not low season when you're rolling out your changes. Next slide. So as I say, we operations just ignores alarms. It says the boy who cried wolf. When at some places I've looked at, they just turn them off because they're tired of seeing them. The system programmers are a very limited shared resource. They don't have time to, set thresholds, and they're too busy, firefighting, which causes loss of productivity in terms of their ability to make the monitoring better or, make application changes. And, one of the things that, our performance people in our environment have is they know the system, they know the typical things that break, and they can solve things a lot faster than new people to the site, even if they're experienced Z people. So, we're having unpredictable workloads for a lot of reasons. One, Agile may have made a change that they said was distributed only, but it hurt us anyways. All the end users are doing self-service. We have a lot more people on and a lot stranger hours than we did when we were just operating a call center, which had most of its volume 9 to 5. And as I mentioned, alarms are set for the worst hour on the worst day. And even if they're dynamic, they're still probably for, the extreme case. So next slide. BMC has come out with an additional offering to the MainView family, BMC AMI Operational Insights, which uses machine learning and does multivariate analysis to generate alarms in real time and provide a timeline of what happened first. So typically when we're looking at a monitor and things went really bad, we may have, 50 alarms and we don't know what the root cause was. And the other thing is those are probably late in being raised because the thresholds are much higher than your normal behavior. This product knows minute by minute what your norm is. It knows what Tuesday at 9:01 looks like and Tuesday at 9:02 looks like, and has a threshold specific to that time, and it looks for deviations from the norm. So that allows us to detect changes in your environment very quickly instead of having to wait or having someone to spend a lot of time trying to pick the right threshold. Next slide. So one of the other things that product is continuously being enhanced, and it has built-in domain expertise. It does all of this analysis. I can detect DB2, DB2 flex, sympathy sickness from another LPAR, but it looks at all the anomalies and looks for patterns between them and creates classification paths. So on the left here, I don't know if you can see my mouse, probably not, but Jeremy's mouse is sitting on classification path 1, and right below it is classification path 2. It tells you what is you know, what it's seeing that's commonality. So you see all these little circles on here, and they actually have shadowed lines between them. But these lines that are going between these are dynamically drawn based on what is occurring at this specific time, and they're all correlated together. So this provides, it helps you when you're losing domain expertise, and it helps you with the, I don't have the right threshold for this time of year when people are allowed to deploy changes, so we can detect issues. Next slide. So in addition to, I mentioned before, we can detect anomalies in application, behavior like CP per tran. We also can have application detection about changes in customer behavior. So I have a volume change that is abnormal, which may be because someone made an application change, but the CPU per tran is the same, but now I'm doing 5 times more of the transaction. So we can detect changes rapidly when they're deployed instead of finding out in high season that we're going to miss our SLA, or we need to raise our caps if we have additional capacity and pay higher costs for software. So this tool allows us to, through machine learning, detect application norms and resource consumption norms and let you know when there's deviations. Next slide.
All right, great stuff, Don. I mean, some of that ML stuff that we're building in is just ahead of its time for sure. Looking forward to seeing where we go with the solution. All right, the last piece is sharing. So sharing is probably the most misunderstood part of the 3 ways. Sharing builds trust. Sharing is a force multiplier through knowledge transfer. Sharing helps to build a culture of teamwork. Dev and infrastructure teams need to share in the victories, need to share in the failures, but they also need to share in the duty and the responsibilities. Whether you're doing Agile and distributed or on mainframe, as I said before, 80% of the data still resides in a mainframe database. So both sides need to be talking. Both sides need to be sharing. What I've been seeing more and more lately is that dev product teams are starting to want to have access to monitoring tools like the ones that Don mentioned, so they can monitor their own applications or even control over database utilities. So things like easy to use GUI interfaces help to bridge that gap. BMC offers GUI interfaces for a majority of our solutions, giving the power to the hands of both developers and to infrastructure teams. Plus, that allows the teams to both talk on the same level when they're talking about what's going on within the environment. Don, what are some other areas that you might see?
Well, one of the things is, people want to know their cost at the business unit level. The bill goes up and you want to know why the bill goes up, and maybe you have chargeback or maybe you don't, but everybody somehow gets a portion of the bill just given back to the business units. And so IBM provides this nice little report on the left that says, the reason for your bill this month was, these LPARs all came together at the same time to create a peak for the machine, and that's all you really see. And you don't know if that peak was basically hit 20 times during the month, and or if it's just one time, and if I attack that one peak, that I could save a lot of money. What you need to see is something more like what's over on the right-hand side, which is I have the peak in red with a little red dot on it where I actually got billed. And I had one other peak, earlier in the month that was about the same, and several other ones that are similar. So that doesn't look like a horrible, amount of things to try to go and attack to find out what's driving that peak and how to reduce it. And so we can look at this data lots of different ways. We can look at it by importance. Was that, purple importance 5 workload? That was, which is what we're seeing here. This is workload by importance. We could also look at it by, subsystems, was it PICs or IMS that caused us to use all the CPU, by service class, by report class, by user-defined business applications, the batch accounting strings, et cetera. Lots of ways to look at the data and see what is driving my cost. So it gives you actionable insight to help you control your cost. Next slide. So the business wants to know, who is driving the bill. And in this particular view over here on the left, where I've got a little box and a check mark, and those red lines, that is a particular batch accounting string. And there's lots of ways that we can classify work into, quote unquote, applications. This was just using an accounting string, but you can see that that particular application spikes over here, similar to the time of the large peak. So that might be worth investigating, in which case we could come in here and say what jobs were running and consuming how many MSUs at that point in time. So these are all of the accounting. You see the workload name accounting that made up that peak, and you could see this one job, and it shows you how much it costs to run. Could that job have been run at a different time? Could that job be run more efficiently? Could someone zip enable it? Whatever, but now you have easily identifiable what I need to attack to reduce my bill. And maybe it's DB2 SQL, and you want to use a SQL Advisor type tool from BMC to help tackle the problem. Lots of ways to look at this and use tools to reduce the CPU. Next slide.
Yep. I just want to add one point there. Your two feedback and plan is spot on. I mean, this is that concept of continuous improvement. If you're not measuring something, if you can't see how things are performing today, then there's no way to improve upon it. And our solution cost analyzer will allow us to go in and take a look at how things are working today, what it's costing us today, and then look for efficiencies, or be able to feed back into the business what's going on. So I couldn't agree more.
Right, and these tools are, if you moved off of 4-hour rolling average billing to, tailor fit, or if you're value unit billing, these tools can still help you identify things that are consuming a lot of resources, because those are costing us money no matter what model we're on.
Yeah. All right. Well, thanks, Don. Bringing it all back together, the gap between dev and mainframe infrastructure teams is not a new one, but it really has been amplified or by the DevOps movement. But there is hope. Applying the 3 principles of DevOps can help you keep up with all that change and keep up with all the pressure coming in from the application product teams. BMC has solutions which feed directly into improving culture, automation, monitoring, and sharing. Feel free to reach out to Don or I. We'd love the chance to share with you more about how our solutions can help you along this DevOps journey. Thanks, everyone.